Hello, my name is David Knezevic. I'm CTO and a co-founder of Akselos. Akselos is a simulation technology company that is a spin-off from MIT. And we provide what we call physics-based digital twins, which are high-fidelity simulation models of critical assets that enable you to run the physics-based analysis, thermal analysis, stress analysis, any kind of structural analysis to understand the current state of your assets. And that enables deep insights into these kinds of critical assets and enables them to be operated more safely, reducing downtime and increasing efficiency of operations. So we bring this in operations and really enable deep insights into critical assets during operations is the key focus. So with that in mind, let me get on to the specifics of our technology in a little bit more detail. The problem we are tackling is that operators who have critical systems often are lacking insight into how to operate these critical systems, because they're very complex and they undergo very many different situations during real operations. And the traditional way to try to deal with this is providing detailed physics-based simulations. But the conventional simulation technology really isn't up to the task of detailed physics-based modeling of critical assets during operations. Conventional simulation technology like finite element analysis or FEA is very computationally intensive, so it can only be applied to parts of assets, not the full system, and it's not fast enough to give insights during operations. So the solution that Akselos provides is a new type of simulation technology we call RBFEA, which is an acceleration and scale-up layer on top of the conventional approach. And this is a patented technology that was developed at MIT, which is why Akselos is a spin-off from MIT. And this enables detailed, fast analysis at the asset level, the entire system level. So you see that instead of just zooming in on small parts of these critical assets, we get the full asset in full view, and we get integrity data of the whole system. And it's set up in a way that can bring in data. So sensor data, inspection data comes into these models, they get reanalyzed, and you quickly get an assessment of the entire system. So this brings the speed and predictive power to support operational decisions when dealing with critical systems. So we've worked in many, many different industries, and here I'll show a couple of examples to, I think would speak to the water infrastructure industry. The first is what we're calling here the world's first digital twin of a pumped hydro station. This is a system in Ireland operated by ESB. And this is essentially a pipe-like system connecting two lakes, which are used to pump water up when you've got excess energy, and you let it come down when you want to use that energy. And of course, this is extremely even more valuable than ever with the renewable with extensive renewable usage that's growing all the time at the moment. And the operation of this asset has changed a lot due to the increased wind and solar that's being deployed in Ireland. So this led to ESB deploying an Akselos digital twin of this system. You can see there's sensor data, which is being tracked here. Every time you get a new sensor reading, you get a new stress profile. This all gets post-processed to give fatigue and strength and critical integrity checks, allowing the operator to understand how they can cycle it, this system in a way that they never had the insight to do in a predictive way before. Now, ultimately, this leads to reduced number of outages and reducing risk to personnel and unlocking further operational capabilities. So many valuable outcomes from this structural digital twin of this asset. Another example is shown here of a pressure vessel. So again, I would think that there are similar examples in the water infrastructure industry of pressure equipment. We also deal with pumps, for example. But you see here an example of a detailed Akselos RBFEA digital twin of a pressure vessel. And what's really special about this is you can see these color profiles on them, which include inspection data. So this is data coming from laser scans of this asset. All that data gets incorporated in the model, and then it gets analyzed. So you get stress profiles, condition checks, so that you understand, is this asset in its current state and its current operating regime safe, or what do I need to do to it, and how do I rank risk of various assets in my portfolio? So this leads to accurate predictions for maintenance and inspection, cost-efficient inspection and repair planning, and reductions in downtime and reduction in maintenance. So these are the types of outcomes from deploying this kind of digital twin, and in particular, connecting it to inspection and sensor data. So there's many things you can do with this type of technology. I think the key is deploying predictive physics-based modeling on assets and using that in operations. We also provide, and this kind of system can also be used in design, but I think operations is the essence of the digital twin. So, but on any of these type of topics, please feel free to contact me at david.knezevic@akselos.com, and I look forward to hearing from you. Thank you.